Let's assume theta is in quadrant 2. Given sine of theta is equal to 5 over 13, find cosine theta and tangent theta. We're going to start this problem by constructing a triangle in quadrant 2 using the information that sine of the angle theta is equal to 5 opposite over 13 the hypotenuse. So here's my triangle with my angle theta. It is in quadrant 2, and I've constructed it in a way where the opposite side of theta is the side length 5, and the hypotenuse is side length 13, because sine is opposite over hypotenuse. Now I want to find cosine of this angle theta and tangent of this angle theta. So I'm missing the adjacent side that's necessary for both cosine and tangent. Well, we can find the missing side length using the Pythagorean Theorem. So the missing side length we'll call b for a moment, and we'll go ahead and use the fact that the two smaller sides squared and added together, so 5 squared plus b squared, has to equal the hypotenuse squared, the Pythagorean Theorem, so 13 squared. So 5 squared is 25, plus b squared is equal to 13 squared is 169. If I subtract 25, I get b squared is equal to 144. And if I take the square root of both sides, I get b is equal to plus or minus the square root of 144, which is nice. It's a perfect square. So plus or minus 12. Now, typically, if this was just a triangle, not in a quadrant necessarily, we would say, well, the side length has to be positive, so the answer would be positive 12. However, we have constructed a triangle in quadrant 2, and this value of b is going left from the origin. So if I go left from the origin, those are negative values on the x-axis, so the value of b I'm going to choose is negative. So b, this missing side length, is negative 12. Now from here, to find the value of cosine of theta, since I have the adjacent side, negative 12, I'm going to say adjacent over hypotenuse, so negative 12 over 13. And tangent theta, tangent is opposite over adjacent. So the opposite side of the angle theta is 5, and we just found the adjacent side was negative 12. In this example, we're given that cosine of theta is equal to 1 over 4, and sine theta is greater than 0, or sine theta is positive. Find sine theta and tangent theta. So this time we aren't explicitly told where the angle theta lies, but because cosine is positive 1/4 and sine is positive, the only quadrant where both sine and cosine, or x and y, are positive is quadrant 1. So we're going to construct a triangle in quadrant 1. And we know that the adjacent side is 1 and the hypotenuse is 4, giving us the following triangle. So here we have our triangle in quadrant 1. Here's our angle theta. Our adjacent side is 1. Our hypotenuse is 4. To find sine and tangent, we're going to need the opposite side. Let's call that b. So now we're going to go ahead and solve for b using, again, the Pythagorean Theorem. So we know that 1 squared plus b squared is equal to the hypotenuse, which is 4 squared. So we have 1 plus b squared is equal to 16. B squared is equal to 15 if I subtract the 1. So b is equal to plus or minus the square root of 15. Now since I'm in quadrant 1, the x distance here is positive and the y distance here is also going to be positive. So again, we know sine and cosine are positive in quadrant 1. So b is going to be the positive square root of 15. Now that we have our missing side length, we can find sine theta and tangent theta. So we know that sine theta is equal to opposite, the square root of 15, over hypotenuse 4. And tangent theta is equal to opposite over adjacent. So the opposite side is the square root of 15, and then over 1, which is of course just the square root of 15.